Thank you, Sue. Okay, I've got just 4 slides here just to run through what we've been doing over the last 6 or 7 years in Pembrokeshire, and just to explain on how we intend going forward over the next 6 or 7, hopefully. So we identified Pembrokeshire back in 2004 as being a key resource and area where we can develop renewable energy from tidal stream. The first thing we did was identify Ramsey Sound as our tidal energy test site. It's got great resource as a test site. It's fast in one direction, there's waves from another direction, it's highly turbulent in one direction. So from understanding the parameters, it's fantastic. We base this around a single turbine deployment on a relatively short-term basis and to enable ourselves to provide high-performance monitoring capability to understand the loads, to understand how the environment reacts to the device and how the device reacts to the environment. So the site is fully consented for 1.2 megawatts. We have a 7-year lease with the Crown Estate, and we hope to be using this as a long-term test platform going forward for the single turbine. Grid export is limited to 1.2 megawatts. The control centre, substation, meter house, power purchase agreement, broadband is all in place. It's fully operational. The right-hand side there, which you probably can't see, is a picture of some green boxes being the power conversion centre with Ramsey Sound in the background. So moving forward after Ramsey Sound, once we've proven the technology, we understand how it works, what do we do next? We appreciate that we couldn't wait for others. However, demonstration zones have come along now, which we might have been a bit wrong there. So we actually took it upon ourselves to identify a site that we can use to show how multiple turbines react and work together in a single site going forward. We identified a site at St David's Head, which is about 2 miles north of Ramsey Sound. Again, Pembrokeshire's got fantastic port facilities, grid facilities, and everything you possibly need to be able to do what we're doing in this particular industry. The agreement for lease has been signed with the Crown Estate. The grid connection is for up to 10 megawatts. I don't believe, though, however, that an array needs to necessarily be 10 megawatts. We just need to illustrate how we connect 2 or 3 turbines together. Next week, we will have completed 2 years' worth of marine mammal monitoring and bird surveys in line with our scoping opinion, and we're ongoing with flow measurement, modelling, bathymetric surveys, and everything else that a site developer needs to do. The diagram on the bottom right is trying to illustrate the flows that we are experiencing when doing our modelling and measurement in Pembrokeshire and around Ramsey Sound. What it is showing is that the flow in St David's Head is not as high as Ramsey Sound, and is a little bit less than we'd actually expected. This enables ourselves to optimize the turbine for the site that we're looking at. And it's been mentioned before, I think Sean from the Crown Estate mentioned, it's pretty much horses for courses. It's trying to design the turbine for the flow that you're going into. The flows are slightly less than expected, as I say, and also the direction. There's about a 15-degree angle between the 2 flow directions, and therefore, we need to design for this. So we're specifically developing our turbine to suit probably lower flow speeds. And there's a synergy here with onshore wind, particularly with regard to the classification for onshore wind turbines. The turbines that we see across at Weir Point are a Class 1 wind turbine, which is used to significantly high wind speed. On the continent, however, they're sort of Class 2, 3, 4 wind turbines, which are this is exactly the same model of turbine, it just has a larger rotor. It's interesting here, the analogy with regard to, in the UK, we're buying turbines from an area with a low resource. It wouldn't be nice to sort of build turbines here in an area of low resource and sell them to an area with high resource, but that's something that we'll have to look at going forward. So basically, the rotor diameter is key to managing to extract the flow, and we're looking to increase that as we go along. The diagram on the bottom right just shows the difference between increasing up the rotor diameter on our turbine from 50 meters, the current design, to 20 meters. We get to rated power before 2 meters a second. So the optimization process for Delta Stream, we still are convinced that multiple turbines on a single foundation should significantly reduce installation cost and material cost going forward. We're looking into how we can connect the 2 generators together, or 3 generators, how many turbines we have, on the device itself, and bring a single cable to shore. The larger rotor diameters are obviously essential, but also the operation and maintenance. Being in an area of larger resource but not quite so fast. It means that it gives us more opportunity to carry out installation, more opportunity to access the turbines for operations and maintenance. And we're now looking at a removal nacelle to reduce the operation and maintenance costs. So that's my fly through. So, okay.
Great.
Thank you.